Good morning, children. Today, our lesson about power and energy of electric appliances from your grade 11, unit 10, right? Power and energy for electric appliances is the 10th unit. Electric appliances. What are electric appliances? Electric appliances are the devices which can be functioned by the supply of electricity. The devices which can be functioned by the supply of electricity. Normally, the electric appliances which are functioning of the electric supply, they convert the electrical energy into another form of energy such as light, heat and sound. Now we'll come to the next topic. How can we calculate the power output of an electric appliances? If we are using an electric appliance in our household purposes that consume energy, whether the electric appliances consumes energy, then the power, it means the work done by that appliance. So we have to calculate how much of the work done by the electrical appliance in a unit time. This is called as power. So you have to clear the definition for power. Power is the work done in a unit time. In electrical field, power is considered as the work done in a unit time or the energy consumed in the unit time. Therefore, the energy consumed by an electric appliance is calculated by the following way. Power is measured by watts. So, to calculate power, we can use this equation. P is equal V I. Power is equal to voltage into I current. Now we'll go through a question. How can we apply this equation to calculate the power? See the first question. Rohan built a circuit with a bulb with 3 volt of each and 2 ampere current flows through in it. Find the power of the bulb. This is the format of the question to find the power. So, as you know, you have to use this equation. P is equal to VI. They have mentioned P. We have to calculate P. They have mentioned 3 volt of the bulb and 2 amperes of current. So, P 3 volt, a bulb with 3 volt, V is equal to 3 and the current used for work done by this bulb is 2 amperes. So the answer is 6 watts. So the power of this bulb consumed, the power uh, consumed by this bulb is 6 watts. We'll see the next question. You're operating your device with 230 volt of power supply. If it has power output of 2300 watts, find the current drawn when your device is working. This question for you, you have to apply this equation. P is equal to V and substitute all the values what they have given. But children, here they have mentioned the value of power as 300 and 2300 watts and the volt of the device is 230 volts. So, in this question you have to find how much the current flow through uh, this device while it consumes 2300 watts of power. So, you have to subject I current in the equation. Electric energy consumed by electric appliances. As you know, power is the rate of consumption of energy. Therefore, the total energy consumed by an electrical appliance depends on time duration. If the energy consumed during a time interval is P, if the energy consumed during a unit time interval is P, the total amount of the electric energy consumed in unit time is PT. So, consumed energy is measured by E is equal PT. This consumed energy, this is energy, so which is measured by joules. So, you know now the equation of calculating consumed energy is equal PT. But as you know earlier, P is equal to VI. We can come up to the derivative equation for consumed energy. E is equal VIT because we are substituting VI into P. So the total energy can equalize voltage into current into times. Right. See the worked example. How can we calculate the consumed energy? The power of the headlight of a motor car is 50 watts. Find the energy consumed by this lamp when it's operated for 2 hours. So here they have mentioned the time duration and the power. So you can calculate the energy directly using the equation E is equal to PT. E is equal P, for P you substitute 50 watts and time 2 hours. Here you go with the uh, conversion of hours into seconds. So we have to write 2 into 16 to 60 joules because we know energy is measured by joules. So this is, here we go, the answer. The amount of energy consumed is 360,000 joules. Right. Now the next topic, efficiency of electric appliances and conserving power. Normally in our household uses, we use several electric appliances. We have the current bill for that at the end of the month, and we admire the amount of the bill, why we have that much. So really children, any sources, not only the electricity, any sources, any resources we have to use with the efficient way, because wasting anything is not good in our day-to-day life experiences. So we'll see how efficiently we can use the electric appliances to uh, conserve power. To save energy, we can use more efficient appliances using fluorescent bulb instead of filament bulb, using immersion heaters to boil water instead of using normal cookers. These are some ways of efficient use of electric appliances. Normal children, electrical appliances are converting electric energy into other form of energy such as heat, light and sound. So most of the electric appliances, they releases heat while they are functioning. So using less heat releasing appliances is more efficient using more heat releasing appliances. So here you go with the question. This question I leave it for you. List out some other ways of consuming energy efficiency in our day-to-day life. Right. Now we'll come to the next slide. Household electric circuit. You have to know what is household electric circuit, because all over our country there is no houses without electricity. So how this electricity produced from the power plants come to our houses? This is the uh, s- this is the content of this household electric circuit. So electric energy required to operate home electric appliances is obtained from national electric grid. The national electric grid, normally in Sri Lanka, in our country, we are producing electricity from hydropower station abundantly. So the flowing water power, it means the kinetic energy of water, rotates the turbine in the hydropower stations, and which activated the generators, dynamos, where they use in the hydropower stations, and these dynamos produce electricity. The electricity produced in the hydropower stations are high voltages, up to 132 kilovolt or 220 kilovolts of electric current produces in the power stations, and these are stepped down by the transformers to distribute all over the island. You all know there are two types of transformers: step down transformer and step up transformers. Step up transformers are increase the voltage what they have gained from the input. Step down transformers are decrease the voltage what they have obtained as an input. So the high voltage of current is stepped down by the transformers, and they are distributed to the distribution centers. The high voltages are lowered up to 32 to 11 kilovolts, and these ultimately lowered down to 230 volt before supply the household usages. Electricity provided to houses in the form of an alternating current with a frequency of 50 Hz. Electricity is provided by distribution wire from the relevant sub-distribution centers. Sub-distribution centers are anywhere we can found in our area. And then we'll see how this electric current is coming from the sub-distribution center to the houses. From sub-distribution center, the electric current comes to distribution wires and supply cables, overloaded circuit breaker and electric meter, isolator, RCCB, MCB, consumer units, switches, sockets and electric appliances. So we'll go through briefly one by one. Distribution wires. Distribution wires are connecting the supply cables of the houses from distribution subcenters. Supply cables. Supply cable supplies 50 Hz 230 volt current from distribution wire to the supply to the houses. These supply wires are highly insulated to avoid accidents. Supply wires are most probably covered by the plastic or rubber insulated materials. Electricity is supplied to houses using service cable consisting two wires known as live wire and neutral wire. These live wire and neutral wires are continuously connected up to the appliances in the household electric circuits from the supply cables. Then overloaded circuit breaker. This is normally called as a service fuse because in the overloaded circuit breaker there is a fuse setup. If we see the last 5 years before or 10 years before, we have the fuse separately and the circuit breaker separately, but nowadays we can find this overloaded circuit breaker as the device to do the function of fuse and the circuit breaker. So let's see what is the function of fuse and the circuit breaker. Fuse performs both detection and interruption function. The circuit breaker performs interruption function only. The detection of the fault is made by relay system. Then let's consider the operation of fuse and the circuit breaker. The operation of the circuit breaker requires elaborate equipments for automatic actions. The operation of fuse is inherently completely automatic, and the breaking capacity of fuse is very small and circuit breaker is very large, and the operating time of the fuse is very small because it is breaking capacity also very small, and the circuit breakers operating time is comparatively larger than the fuse. And the replacement, whether we want to replace the fuse, requires replacement after every operations, but in the circuit breaker no replacements after operations. Electric meter. Next device what we are connecting into our household electric circuit is the electric meter. As you all know, the meter records the electric energy that consumed in kilowatts hours. The live and the neutral wires coming through the service fuse are next connected to the meter. These are next connected to main switch. Electric meter and overload circuit breakers are the properties of the service provider. Who are the service providers? Service providers are the electricity board, those who are provide the service to us. And the next device what we are connecting in the household electric circuit is isolator. Isolator is the disconnection switch and to be operated on no load. Isolator is also capable of switching with the charging current and also break the bus transfer current, which are its functional requirement. So isolator normally do the braking function whether the overloaded current passes through in it to maintain the service. And the next device what we are connecting to the electric household electric circuit is RCCB. RCCB stand for residual current circuit breaker, or we can call this as a trip switch. After the isolator, the live and the neutral wires are connected to RCCB. The function of RCCB is protecting the resident from electric shocks. When there is a current leakages occur in the circuit, this RCCB automatically disconnected. RCCB is a dual pole switch. And the next device to connect in the household electric circuit is MCB. MCB, the stand of MCB is miniature circuit breaker, or we can call this as fuse. MCB supply electricity to the each connection inside the distribution box. When large amount of current passes through, MCB automatically disconnects the circuit and lever shifts down and come to the off position. Usually we can see in the switch sockets on-ing position is lever come to down, but here in the miniature circuit breaker the off position the lever comes down. For a lamp circuit, MCBs which can conduct a current of 6 amperes, and in the socket circuits which can conduct the current of 13 amperes. And MCBs can protect electric short circuits and resulting wire due to heated cables only. So this MCB is the main device which protect the devices, protect our household electric circuit devices connected to that by disconnecting uh, if load of current comes through the circuit. After that, consumer unit or distribution unit. These consumer units or the distribution units are can only found nowadays in our country. Earlier, MCBR, Isolator and RCCB all are separated in the household electric circuit. Nowadays, we can observe these into one pack of distribution box. All the main switch, circuit breaker, MCBR all are in the distribution box. So consumer units can be observed only in modern circuits. In modern circuits, isolator, RCCB, MCB are included in here. Consumer unit is called as a distribution box as well. Let's move to the next device which is connected to our household electric circuit, that is switches. Switches used to turn on and off the power devices. We may come across different shapes and sizes of switches. They are able as single units or available in single units or in unit consisting of several switches on the same board. The main function of switch is used to turn on and off the power device. The next device is connected to the electric circuit is plug sockets. See the pictures. There are different types of plug sockets. Plug sockets are the circuit element where live, neutral and earth wires are connected to the circuit until from the supply cable to the sockets live and neutral wires are connecting, and with this the earth wire also connected to the socket. The larger terminal of the 3-pin plug socket is connected to the external metal cover of the electric appliance, and it connected to the earth wire in the domestic electric circuit by plugging on. Neutral wire connection is essential in order to protect from electric shocks. Let's we move. What is the next thing? That is earth wire. You might see by operating these kind of plugs, 2-pin sockets are not connected to the earth wire. There are 3 colored wires: brown, green and blue. Brown color wire always indicate the live wire. Green wire is indicating the earth wire and blue wire is indicating the neutral wire. So 2-pin sockets normally they don't have the earth connection. Connecting wires with 1 square millimeters cross section area are used in order to carry 5 ampere or 6 ampere currents. More than this cross section area of the wires are conducting 13 or 15 ampere currents. In 3-pin sockets, we can observe earth wires normally. Domestic electric circuit. This is the picture of domestic electric circuit, household electric circuit, from the pole, how the electric current is coming to the meter, and MCCB, RCB, and circuit breaker, and all the devices connected to the electric appliances in household purposes. In domestic electric circuit, bulbs and plugs are connected parallel to each other. All the switches should be connected to the live wire. Plug circuits are connected to the cable withstand the current of 13 ampere. These kind of plug circuits are in the kitchens. Normally, in the kitchens we are using heavy devices such as fridge, microwave ovens, and some heavy devices, devices. Sometimes plug circuits are connected to the ring circuit. Cables with smaller diameter can be used in the ring circuits. And now come up to the uh, measurements of electric energy. How electric energy is measuring in kilowatts and hours. This is the equation. 1 kilowatt hour is calculated 1000 watts hours. 1000 joule per seconds for 1 hour. It means 1000 into 60 into 60 joules. So 3000, sorry. So this 3.6 megajoules of amount of electric energy can be measured in 1 kilowatt hour. Right, here we go with the calculation part, how to calculate electricity consumption for a month. So if we know a device is consume electricity, which is used the electric power, then if we are using 5 bulbs, each have the power 100 watts for 5 hours daily in a month. So consumption of electricity from the calculation, 5 bulbs per 500 watts into 5 hours. So we can multiply all these values. Whether though it is in hours, we have to convert this watt into kilowatts. So I divided this by 1000. Then you will get the answer 2.5 kilowatt hour. That is for day, per a day. But the question is calculate the amount per a month. So you have to multiply this amount into 30. Then you will get the answer like this, 75 kilowatts hours. If we have several devices, we have to add all the values together. In household electric circuit, we don't have not only bulbs are there are several devices. So we have to calculate the electric consumption for each device separately and add together. For an example, we are using 5 bulbs with 100 watts, 5 hours per day, a television with 250 watts, 3 hours per day, and a 150 watt of washing machine 1 hour per day. So calculating this consumed electric energy for a bulb, television, washing machine. So I substitute all the amount in the uh, equation how we want to calculate, and finally I come up to the answer 3.4 kilowatt hours are consumed in a day. Then this means 3.4 kilowatt hours of energy consumed in a day means 3.4 units used per day. Unit conversion into rupees. So if we convert the units from the energy consumption, we have to know how these calculated today. electric bills. We all know the service provider is mainly the electricity board. The calculation of the consumption of electric energy and the meter reading billing are done by service providers. To calculate the amount of consumptions, they have the billing system. For example, if we are using 1 to 30 units, they will they will take uh, 30 rupees or whatever the amount, 30 to 60 units, whatever the unit rates. So they have the rates of unit until the limits of the units. So then calculate the units as per the amount. So as our previous example, we come up to the 3.4 units or 3.4 kilowatt hours per day. So per day, if we calculate 3.4 unit is come between 1 to 30 units. So for 1 to 30 units, we can calculate with the 30 rupees. So 102 rupees of the electricity bill uh, consumed should be consumed for as per the earliest example as a electric bill. This is the way how to calculate the conservation of electric bill. Here you go with the questions. There are a few questions. An electric lamp bulb of a motor car is labeled 12 volt 0.5 ampere. First question, find the power of this electric lamp bulb. Second question, calculate the energy produced if the bulb lamp is worked 30 seconds. Third one, calculate the consumption of electricity if you are using the electric lamp bulb in your vehicle 3 hours per day. Question D, find the monthly power consumption of your vehicle. As we earlier discussed, you can go through the steps by step to find out the answers. And the next question, calculate the number of electric units consumed by each instruments. Here I have given you several instruments with their power consumption. So you have to calculate separately all the power consuming units and calculate the total energy consumption, calculate the monthly consumption and calculate the electricity bill per a month. So consume per day and multiply by 30 and you go through with this. Thank you children. This is up to our lesson electric appliances, power and energy for electric appliances. We'll meet with the another lesson. Thank you. Goodbye.